Let's look at a few examples of the rational root theorem. So one question you might get asked is to list all possible rational roots of p of x. All right, and remember, rational roots, we're finding the factors of q divided by the factors of p, where q is the constant term and p is the leading coefficient. Okay, so remember last over first. So the factors of q are just plus or minus 1 and plus or minus 3. The factors of p, this leading coefficient, which is 2, are plus or minus 1 and plus or minus 2. All right. If we want to make a list of all possible rational roots, okay, and again, these are not the actual rational roots, these are just the list of possibilities that we're going to test. All right, you need to look at the numerator and the denominator. So the first numerator-denominator group we're going to look at is this 1 over 1. Okay, and when I'm doing this, I'm going to say, well, 1 divided by 1 is 1, and 1 divided by negative 1 is a negative 1, and there's no other combo that's going to get me anything different. So this group right here is either positive 1 or negative 1. Okay, and then we're going to go to now 3 over 1. 3 divided by 1 is 1. That's a lie. 3 divided by 1 is 3. And 3 divided by negative 1 is negative 3. So our options for, or our possibilities for that, there we go, are plus 3 and minus 3. Okay. Now we have to account, so we've done both numerators and one denominator. All right, now we need to do both numerators with the second denominator. So we're going to do 1 divided by 2. And 1 divided by 2 is 1/2. The positive version and the negative version. And then the last one we're going to do is 3 divided by 2. So you get 3 over 2. And this right here is the set of all possible rational roots. Again, these are not all the roots of the problem. They're just the possible rational ones that you could choose from. And if it just says list the possible rational roots, that set is your answer. Those are the possible ones. You've done it. Okay, so now let's look at another example. All right, we have this polynomial p of x, and we want to use the rational root theorem not only to find the possible rational roots, but to factor the whole thing. All right, this word factor means we want to break it up into all its pieces. So we're going to start by using the rational root theorem. Okay, so step 1 is to use the rational root theorem, and we're going to list the factors of p over the factors of q, over the factors of p. Sometimes I get the letters mixed up. I always remember the last number over the first number. Okay, so plus or minus 1, plus or minus 2. Those are the factors of the constant term. And then the leading coefficient is 1. So factors of 1 are just plus or minus 1. If I go list those out in a comprehensive list, 1 divided by 1 is 1, plus or minus. 2 divided by 1 is 2, plus or minus, and then there's no other denominator to divide by, so that's it. That's my list. I have 4 options to try out. So the second step to this problem is we're just going to try out the options until we get something. So let's try out 1. I'm going to put 1 in the box, and then I'm going to list the coefficients out. I have 1, 4, 5, 2. I'm going to drop this 1 down. 1 times 1 is 1, 4 plus 1 is 5, 1 times 5 is 5, 5 plus 5 is 10, 1 times 10 is 10. This is not going to equal 0. So it equals 12, but once I know it doesn't equal 0, I don't really care about it anymore. So 1, not an option. Okay, no good. Let's try another one. So I'm going to erase this, and instead of 1, let's try negative 1. So I'm going to try negative 1. I'm going to list out my coefficients, 1, 4, 5, 2, and I'm going to do my synthetic division. So I bring down the 1, negative 1 times 1 is negative 1, 4 plus negative 1 is 3, negative 1 times 3 is negative 3, 5 plus negative 3 is 2. Negative 1 times 2 is negative 2. Hey, this is exciting. Remainder 0. So I have found a root, 0 of this function, and that is negative 1. And it works because it has a remainder of 0. Okay, so that means if I'm going to factor out p of x, my first factor is this one that I just found. It's the factor that goes with the root negative 1. And the factor that goes with that root is x plus 1. And that's its factor because negative 1 is the value that makes this factor 0. Well, now let's go down here and figure out what the rest of the polynomial looks like. So I divided a cubic by a linear term, so I'm going to end up with a quadratic, a squared term. So I have 1x squared plus 3x plus 2. I'm going to say, well, hey, is that something I can factor? And it is. This factors into x plus 2, x plus 1. So now these are the 3 factors that make up p of x. So if you're going to give me a nice, good looking answer here, p of x is equal to that first factor I found, which is x plus 1, and then this guy all broken up, which is x plus 2, and then this is a second x plus 1, so I could list it again, or I could say squared. And remember, if one of my factors is squared, we say it has a multiplicity of 2. So this is my final answer right there. Let's look at one more example. All right, here's my polynomial. I'm going to start by doing the rational root theorem. Okay, factors of q over factors of p. So in the numerator, I just have the factors of negative 1, which are plus or minus 1. In the denominator, I have plus or minus 1, plus or minus 2, and plus or minus 4. Those are the factors of 4. All right, so I'm going to make my list. 1 over 1 is 1, and then that's plus or minus. 1 over 2 is 1/2, plus or minus. And 1 over 4 is 1/4, plus or minus. So step 2 is to try it out. So I'm going to just test numbers until I get one that works. I'm going to start with the easy ones. Hopefully 1 or negative 1 will work so I don't have to deal with fractions. I put 1 in the box. I'm going to list my coefficients. 4, negative 9, 6, negative 1. Drop down the 4. 1 times 4 is 4. Negative 9 plus 4 is negative 5. 1 times negative 5 is negative 5. 6 minus 5 is 1. 1 times 1 is 1. Hey, look at that on the first try. What a winner. So that means 1 is a factor, or 1 is a 0. And the factor that goes with 1 is x minus 1. So the first factor of our p of x is x minus 1. Okay, let's come down here and find the rest of our factors. We divided a cubic by a linear term. All right, so we're going to start, this will always be 1 less. So if I started with a cubic, then this will be a squared, a quadratic. 4x squared minus 5x plus 1. Okay, and I can either use the AC method or I can guess and check. I'm going to go out on a limb here and guess and check. I'm going to say 4x plus something and x plus something. Oh, this is a plus and this is a minus, so one of these has to be a minus. Let's look at these numbers here. I've got to have 1 and 1. So I want, both of these have to be a minus because of that. So this has to be a minus, this has to be a minus. Let's check it out. Negative 4x, negative 1x, that gets me negative 5x. Those factors are correct, so I'm good. So I'm going to list my p of x. My final answer here is that first factor I found, x minus 1. Note that in this one that's repeated as well, so I'm going to give that a squared. and then 4x minus 1. And that is the final factored form of p of x.